Hello guys, welcome to my channel, and this is the third video in pre-ACT and ACT math review. And in this video we're gonna learn few more basic concepts that you must need to know before you even start preparing for your SAT and ACT. So we're gonna go over those concepts just to review it. You might remember them or you might forget them, so please watch the video, and I'm gonna solve some examples too, just in case. Okay, so let's start with in the first topic we're gonna start here is coordinates. Let me write it down. Coordinates. So before we dig into coordinates, let's look at this graph over here. So this side, they call it the y-axis, and this is our x-axis. So this is, let's say, 0. So above 0 is positive y value, and below 0 is a negative y value, and to the right it's positive x value, and to the left of 0 it's negative x values. Okay, so negative y over here. So this quadrant, x and y both are positive, and this second coordinate, call it quadrant, so x is a negative because we are to the left, and y is positive. And in this one both x and y are negative, and in the fourth quadrant x is a positive but y is negative. So let's say if somebody asks you graph this coordinate on this graph over here, let's say I got -1 and 4. So first of all, this first value over here is x value, and the second value is our y value. So -1 and 4, x is a -1. Assume each box is 1 unit, so this value is over here. So x is a -1 and y is positive 4. That means we need to go up 4 points. 1, 2, 3, 4. So this is the coordinate here. So this point represent x is a -1 and y is positive 4. All right, now let's say the second point is 3 and a -5. So let's find out. So x is 3, positive 3, so we're gonna move to the right of a 0. So 1, 2, 3, and y is a -5, so we're gonna move downward because y value is negative. So 1, 2, 3, 4, 5. So this point over here, x is 3 and y is -5. So that's how you can plot those points on this coordinate plane. Okay, in 2 dimension they call it. So next topic is slope of a line. Slope of a line. Let's say if I join these 2 points here to make a line. Okay, and this, and find the slope of this line. So before we even find the slope, we need to know what does slope means. Slope basically measure how slanted this line is. If it's falling down or it's rising up, so that is measured by a slope. And the formula to measure the slope is, so slope, they sometimes represent it by m, okay, in line equations. So slope m, let's say, is equal to rise over run. So rise measure the change in y value. So rise is change in y value, and run measures change in x value. Let's say we are going from this point to this point, how much change is there in y value over the change in x value? And it can be written as, let's say these 2 points are x1 and y1, and these 2 points are x2 and y2. So the change in y value is basically y2 minus y1 over x2 minus x1. So to measure the slope of this line, we just need to plug in those x1, y1, y1 and y2 value into this formula over here. Let's do that. So y2 is -5, and then this negative sign, and y1, that is 4. Then we got x2, which is 3, minus x1 is -1, so -1 over here. So negative minus -5 minus -4 gives me -9, and 3 minus multiply by minus becomes positive, so 3 plus 1 gives me 4. So this is -9 over 4. The slope of this line is -9 over 4. So when the other thing you need to know, if slope is negative, that tells me this line is falling down, and you see this line is falling down. A negative slope also means if the one value is increasing, the other value is decreasing. So in this case, our x value is increasing to the right, but the y value is decreasing, going negative. Okay, so negative slope means line is falling down, but if slope is positive, that means line is going up. Okay, so positive slope line might look like this one. Okay, see, the value is going up, the line is rising. All right, so that line, like this line, will give you a positive slope, and you guys can do a couple of examples to see that, and it's fairly easy. All right, so let's move on to the second part, the equation of line. So standard form of line is written as standard form of line. So it's written as ax plus by is equal to c. And let's use examples. So if I say 2x minus 3y is equal to 7, so this is the equation of a line, and this is a standard form of a line. There is another form which is, y is equal to mx plus b. So this is called slope-intercept form, where m is a slope and b is your y-intercept. But in this format, this is a standard form of a line, and we can graph this line. Okay, so if they give you a standard form of a line and they ask you to graph it, you can use the intercepts over here. So let's find out what are the intercepts. So what we need to do, we need to find the x-intercept. So x-intercept means y is equal to 0. So we need to find, so if we graph this line, wherever this line crosses the x-axis, wherever the line intercept the x-axis, so that's where the value of y will be 0, and that will be your x-intercept. So let's say if you're finding x-intercept, plug in the other variable 0, which is y here. So to find x-intercept, I need to plug in y is equal to 0 there. So that gives me 2x minus 3 times 0 equal to 7. Therefore, 2x, so 3 times 0 is equal to 7. So divide both sides by 2. And this 2 will cancel this 2. Therefore, x is equal to 7 over 2, which is 3.5. So that is your x-intercept. And now if I have to find a y-intercept, so let me write that down. So y-intercept, that means x is equal to 0. So y-intercept means this line crosses the y-axis. That's the point. We call it y-intercept, and that's where the value of x is going to be 0. So whenever we are on the y line, y-axis over here, x is 0. Okay, so y-intercept means x is 0. So plug in that over there. So 2 times 0 minus 3y is equal to 7. Therefore, negative 3y is equal to 7. divide both sides by -3, and this gives me y is equal to -7/3, which is equal to approximately 2.33. So we got 2 points here. So first one is x is 3.5 and y is 0, and second one is x is 0 and y is -2.33. So let's graph these points on the graph over here and then plot a line or graph a line. God. Okay, so first one is 3.5 x value. So let's say this is 0 where x and y both are 0. So x is 3.5. So assume each box is a unit. So 1, 2, and 3 and halfway here, and y is 0. So this is the point, which is 3.5 and 0. And the second point is x is 0, which is here, and y is -2.33. So this is 1, this is 2, and I'm gonna say it's almost here. Okay, so this point over here is 0, -2.33. Uh-oh, what did I do? Okay, so sorry about that. This happens sometimes. Let me fix this first. Okay, delete and delete. All right, so we got 0 and -2.33. This is the point over here, and this point is 3.5 and 0. Now if we join these 2 points, that will be our line. You extend it, and it looks like this line is rising, so the slope is going to be positive in this case. Okay, so that's how you can graph a standard form of a line. And if they give you equation in slope-intercept form, we can graph that line too. Let me go to the next page. So if the equation of line is given in slope-intercept form, so slope-intercept form of line, not line, the line. So it's y is equal to mx plus b, where m is called the slope of the line and b over here is called y-intercept. Okay, and let's say we have an equation of line y is equal to 4x plus 5. So in this case, slope m is equal to 4 and y-intercept is 5. So that means when x is 0, y is 5. Okay, so how to graph when they give you equation in slope-intercept form? Very easy again. You might already know or you might forgot, so just review it. So first step is find your y-intercept point on the coordinate system. So x is 0, y is 5. So this point again is 0, 0. X is 0. So we are here. Y is 5. So 1, 2, 3, 4, 5. So this point here is 0 and 5. And now we're gonna use the slope to find the second point. So remember, slope m was rise over run. So we got 4, which is basically means 4 over 1. So that means we're gonna rise 4 points, then we're gonna run 1 point to the right because it's positive. And again, y is positive, so we're gonna rise upward. Okay, so y, change in y is 4, so we're gonna go up, rise 4, 1 from this point, from the y-intercept, so 4 up, 1 2 3 4, and 1 run, so to the right. So this is my second point we found by using the slope. And now you just need to join those two points, and that will give you your line. Okay, and here if you see slope is positive, that means line is rising. So you see this is rising up. All right, other thing we can learn, let me find this point too. X is 1 and y is 1 2 3 4 5 6 7 8 9, so 1 comma 9. Next thing you guys need to know the distance formula. So that formula basically help you to find the distance between 2 points. Okay, so for example, these 2 points on a line segment, this is line segment over here, from here to here, they said find the distance between those 2 points. So what you need to do, you need to use a distance formula, and that is basically, let me write that down. So let's say these points are x1 and y1, and these points are x2 and y2. So distance formula says distance is going to be equal to square root of x2 minus x1 square plus y2 minus y1 square. So you plug in the values of x2, x1 and y2 and y1 in this equation and solve for the distance. So let's do this one. So x2 is 1 and x1 is 0. 1 minus 0 square plus y2 is 9 minus y1 is 5 square. So it's going to be square root of 1 square is 1, 9 minus 5 is 4, and 4 square is 16, and 16 plus 1 is 17, so square root of 17. So distance between those 2 points is basically square root of 17, and you can use your calculator to find this. All right, and the other thing other than distance is midpoint. So let me write that down too. Midpoint. So let's say what are the midpoints for this line segment, like in the middle, right? So how we can find the x coordinate and the y coordinate for the midpoint of the line segment? Okay, so what we're gonna do, so midpoint formula is, they represent it by m is equal to, we're gonna find the average of x points, so x1 plus x2 over 2, and average of y1 plus y2 over 2. So in our this example, so x1 is 0 and x2 is 1 divided by 2, comma, y1 is 5 and y2 is 9 divided by 2. So this is going to be equal to, so 0 plus 1, 1 over 2 is half, 0.5 or 1 over 2. 9 plus 5 is 14, divided by 2 is 7. So half and 7 is going to be our midpoint. So if I go half from here to here at this point and go 7 up, 1, 2, 3, 4, 5, 6, 7. So this point over here is my midpoint to this line segment. Okay, so they can ask you problem in different ways. You know, they give you midpoint midpoint and one of the coordinate and ask you to find the other coordinate, because SAT or ACT problems are not going to be like straightforward. These formulas, you can use this formula to solve those, but again the problems are not going to be straightforward. So they'll give you something and ask you to find a midpoint, or they give you the midpoint and ask you to find those x or y coordinates. Same thing with the distance. But you need to know these basic rules first before you solve those problems. So that's the goal of this video is. Okay. So next topic I'm gonna go over is, let me do this after this one, or let's do this one. So functions. Okay, so let me write it down. I'm gonna go back to this page later. So functions. Okay. So in function, I've made another video on that too, I believe. So it's like a machine or a system. Let's say there is this machine. You plug in one value and you get another value. So basically you plug in x value and you get a unique y value for that particular x value. So that is called a function. For example, if you got, and it's represented as f of x, and you get a y value. So y is basically f of x, and this is equal to, let's say, 2x. So now you plug in the x value and you'll get a unique y value. No one x value gives you two y values. Okay, for example, if you plug in x is equal to 1, there will be y is equal to 2 times 1 is 2. So that means when x is 1, y is 2. You can't get y is equal to 5 or 6 because plug this x1, x is equal to 1 here. You just get 2 times 1, which gives you 2. So you get a unique y value, only one y value for one x value. So this is called a function. And there are like different types of functions I'm gonna go over here. So one of them is if f of x, the function, is a constant, let's say c, then it's called a constant function, and the graph of a constant function is a horizontal line, because basically this is y value, y is equal to c. So let's say if y is equal to 2, where is, so 1 2 1 2 1 2 1 2, if y is 2, so this is the point over here. So even if you are here, y is still 2, so this is the y value. If you are here, the y is still 2, or if you are here, y is still 2. It's constant, it's not changing, it's going to stay 2 forever. Either you're going towards left or towards right. So when you join all those possible points, it's a horizontal line. So constant function gives you a horizontal line, or the graph of a constant function is a horizontal line. And if, let's say, second kind of function, if f of x is equal to x, it gives you the same value whatever you plug in. Okay, whatever you plug in, the y value will be same. So if x is 0, so this is the function, y is f of x is x. So now if you plug in x is equal to 0 here, okay, so if x is 0, y is also 0. If x is 1, y is 1 here. So this is basically y is equal to x. So this kind of function is called identity function. Okay, and the identity function's graph is going to look like a diagonal in this coordinate plane. So it will be like this, a diagonal. This angle will be 45 degrees. So this will be the graph of a identity function. Okay, and third type of function is going to be monotonic function. So monotonic function. So if this function, the monotonic function, is always increasing or always decreasing, so that function is called monotonic function. The example is, let's say f of x is going to be 2x. So whatever value of x you are plugging in, this function going to keep rising. Okay, x is 2, then y is 4, x is 3, y is 6, x is 4, y is 8. So the function is always increasing. So this is a monotonic function. The others are, if it's keep decreasing, in that case function is, for example, I'm going to use the negative exponential function. So in this case the function is decreasing. So this is called monotonic function. An important, I'll say very useful, even function. You might see problems on those in your algebra 2 class, I believe. Even function. So if the function f of x is equal to f of negative x, so if you plug in the negative value of x and both values are same, that kind of function is called even function. And one of the example of even function is if f of x is x square. So if you plug in, let's say x is equal to 2 here, so that gives you 2 square is equal to 4. And now let me write down again, and now you plug in f of negative 2 here. You see x is positive here, x is negative here, so negative 2 square is also going to give me 4. So f of 2 is equal to f of negative 2. So this kind of function is called even function. And the opposite of that is odd function. So if f of x is equal to negative of f of negative x, then this function is called odd function. So example, the easy example or the very common example is x cube, right? So if I plug in f of 1 here, so this gives me 1 cube, which is 1. Now if I plug in negative 1 over here, so that gives me negative 1 cube, which gives me negative 1. So f of 1 is equal to negative of f of negative 1. See, let me show you. So this is a negative and f of negative 1 is negative 1, which makes it positive 1. Then both are equal. So this kind of function is called odd function. And we can use a vertical line test to find out if the graph is a function or not a function. So they call it a vertical line test. Vertical line test. You might see a problem on that, but again, this is a basic example. So vertical line test is used to find the graph is either a function or not. Okay, so graph is a function if each x value, so each x value gives you unique y value, only one value of y for one value of x. So let me just make a graph over here, couple examples. Okay, and we got a graph that looks like this. Let's have parabola over here. Okay, so vertical line is, they said draw a vertical line that passes through the graph of this function. So let's say if I graph a line over here, okay, and you see this line passes through only one point on this graph. This is the point. So this is the x value, and for this particular x value we are getting only one y value. That means this graph is a graph of a function or this function. So this is a function here. Now let's say if I got another graph, let me draw it. And graph looks like this. And they said tell whether this is a function or not. Again, we're gonna use vertical line. I drew a vertical line that passes through this graph. Doesn't look like straight, but assume it's a straight vertical line. And now you see this vertical line passes through 2 points or crosses 2 points on this graph. So for this one value of x, this is one value of y, and this is another value of y. So that tells me there is more than one y value for one given x value. So this is not a function. This is a function. Let's draw another one. Okay, and the graph looks like something like this, let's say. Okay, and now draw a vertical line through the graph. And this vertical line crosses many points on the graph. That tells me for this one particular x value, this is one y value, this is another, this is another, this is another. So 1, 2, 3, 4, 5, 6, 7, 8, 9 y values, which is not possible in a function because each x value gives you only one y value. So this is also not a function. All right, so that's how you can find if this graph is a function or not. Okay, and before we do that, there is one more thing that is called inverse of a function. So we study function. Now let's go over inverse of a function. Let's go to the other page. Inverse of a function. So they gave you a function and they said find the inverse of that function. And the example I'm going to use is, let's say y is equal to 2x squared. So it's a function. It's a parabola, quadratic function. Okay. And they said find the inverse of this function. So to find the inverse of a function, the step one is switch x with the y. So x to the y and y to the x. And then solve for y. Okay, so switch x to the y. So this x becomes y and this y becomes x. So that'll be rewritten as x is equal to 2y squared. Okay, so that is, now we're gonna find the value y here. What we need to do, divide both sides by 2 because we just need y. So this 2 will cancel this 2. So we'll get, therefore, y squared is equal to x over 2, or can be written as y is equal to square root of x over 2. So this is the inverse of this function. Okay, and now let's say they said graph the inverse function of this function. Okay, so first of all, let's graph this function. So what we need to do, y is equal to 2x squared. So we're gonna make a table for x and y values, x and y. So plug in x value, find the y value, and I already wrote, and you can write down or solve by yourself too. If x is negative 2, y is 8, x is negative 1, y is 2, x is 0, y is 0, x is 1, y is 2, x is 2, and y is 8. This is just, they gave you this. And they said graph the inverse of this function. Then you don't have to find the inverse. You just need these points. And what you need to do is, so this is my function, the points, the table, and the table for inverse of a function will be switch the x and y values. So x and y, so this is the y value over here 8, so it will become the x value for the inverse function. These values are for inverse function, and x is 8, y is negative 2, so y is 2, so that will become x 2 and negative 1. The 0 0 stay the 0, so 2 and 1, 8 and 2. Now these are the points, or this is the table for inverse function, and you can use these points to find the graph of inverse function. And we can check it over here if it's right or wrong. So y is equal to square root of x over 2, and see if it works. If x is 8, okay, so y is, if x is 8, if I plug in 8 over here, so 8 over 2, which is basically square root of 4, which gives me plus minus 2. See, we got negative 2 and plus 2 when x is 8. So that means these points are right. Okay, so again, they gave you a function, they gave you the points or the table, and they said graph the inverse function using this table. So you need to make another table for inverse function. That's where you're gonna switch the values of x and y from the given function. So y value becomes x value and x value becomes y value for inverse function, and you can graph it. All right, so that is called inverse function. So next thing we're gonna work on is graphing quadratic function. So let's go back to the graph. I have few graphs over here. Okay, so graphing quadratic functions. Quadratic functions. So quadratic equation or the function looks like y is equal to ax square plus bx plus c. Okay. And the most easiest or most general quadratic function will look like y is equal to x square. And in this quadratic function, a cannot be equal to 0. B and C can be, but a is not. So in this function, a is 1, and we'll go over it, what this a does to the function. So this is the most common or most general form of a quadratic function. So that's where a is 1, all other factors are 0. Okay, and we're gonna graph this function. Okay, so what you need to do, again, make a table. So you have x value, you have y value. So plug in x here and find the y. Let's say x is a negative 3. That gives me y is going to be 3 square is 9. Negative 2 gives you 4. Negative 1 gives you 1. 0 gives you 0. 1 gives you 1. 2 gives you 4. And 3 gives you 9. Okay, so now plot those points over here. Can use a red. So x is a negative 3, so 1, 2, and 3, and y is 9, so 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is my first point. And second point is x is a negative 2, 1, 2, and y is 4, 1, 2, 3, and 4. So x is 1, y is 1. And then the other side will be just the reflection of the point from the left hand side. I'm going to be here. then it's going to be here. Now join all the points. So it will look like something like this. Okay, not the best, but so it will look like this. So this is called quadratic graph or quadratic function, and it's called a parabola. Okay, let me fix this. I don't like it. I'm gonna draw it better than that, I believe. Okay, so go from there. Okay, and you keep going through this point and this point. I'm not good at drawing here, so okay, so this is the graph of this quadratic function, and they call it parabola. Okay, and in this parabola, this point over here, so this is called the vertex of the parabola. So that defines the minimum or the maximum of the graph. So parabola is either opening upward or downward. It can be left or right too, but in this case, just gonna go over basics. So this parabola looks like it's open upward, and this point is our minimum point, but this is called our vertex. Okay, so for this parabola, vertex is the minimum is 0, 0. Okay, and the vertical line, so this line, which is our y-axis, so this vertical line that passes through the vertex of parabola is called symmetric axis or axis of symmetry. So our parabola is symmetric to this axis. So basically you see a reflection of a parabola on the other side through this axis. It's called the axis of symmetry. Okay, and the fun fact I'll say, so this a value over here, you see a, so a is 1 in our case, a is equal to 1. So now if a value is greater than 0, then our parabola opens upward. If a is less than 0, then it opens downward. Let me pull up my graphing calculator and I'll show you what it looks like. So I use Desmos for all these graphings. Okay, so we got y is equal to x square. See, this parabola is open upward. And now if I put, so a is positive 1, if I put negative 1 over here, so negative 1, you see it's now open downward. Now this point over here, again, this is our vertex point. So when the parabola open downward, now this is our point of maximum, so maximum of the graph. But when it's open upward, then this is a minimum of the graph. Okay, so let's go back to our page. So with a negative a value, it will open downward like this. Okay, and the other thing you can learn, domain. So domain of this parabola is going to be, the x value, it's going up. Okay, so domain is, so the graph is going in this way, going up, and you see x value is increasing to this side, and x value is, when it's moving to this side, x value is also increasing. So x value is going from negative infinity to positive infinity, and the range starts from the 0 and 0 is included, so I'm gonna make a square bracket over here, and it's going towards positive y value towards infinity, so positive infinity. So this will gives you the range of this function. Okay, and some formulas, I'm gonna write down some useful formulas over here. So the line of symmetry, find the line of symmetry, which is basically what is the value of x. So in general, let's say this is the equation of quadratic function, and they said find the line of symmetry. So line of symmetry, which is x, which is equal to negative b over 2a. So this gives you the line of symmetry for the quadratic function. Okay, and vertex. So vertex is going to be, you know, the x value minus b over 2a. You plug in that minus b over 2a in your function over here, that'll give you the y value. So basically f of x. Okay, or instead of x, I'm gonna say minus b over 2a. So this will gives you the vertex. There is another formula, or it's minus b over 2a. This is the x value for the vertex, and y value is going to be minus b square over 4a plus this constant c, or use this formula to find the vertex. Okay, and y-intercept. So let me write down y-intercept. That means when x is 0. So if you plug in x 0 over here, y is going to be c. So y-intercept is basically this constant c. And x-intercept, you already know this axis of symmetry gives you that. So x-intercept is going to be negative b over 2a. So those are some basic formulas you guys can remember if you are looking into this function, quadratic function. So a will tells you if it's open upward or downward. And another thing, so about this a, if the value of a is greater than 1, this makes graph more narrow. So this makes this graph more narrow. Let's go back to the calculator again. So if a is greater than 1, so let's say, so this is the graph for x is equal to 1. I'm gonna make another one. So y is equal to, now a value is greater than 1. Let's say it's 2. And see, so this blue graph is our new graph, which is much narrower than the first graph, which is this one. So y is equal to x square is a wider, and y is equal to 2x square is a narrow. Let's make another one. So let's say y is equal to 10x square. See, now it becomes more narrow. So as the a value is increasing, our graph is going more narrow and narrow. Okay, let's go back to the screen. So if a is going greater than 1, it's increasing. That is going to make our graph more narrow and narrow. And now let's say if a value is greater than 0 but less than 1, that makes graph wider. Okay, let's go over to that one. As the value is going towards, as the value of a going towards 0, the graph will be more wider and wider. So let's go back here. Let me delete these. Okay, so this is y is equal to x square. Now if y is equal to, so it's going to be less than 1, so 0.7, let's say. You see, the purple is the new graph. The a value is less than 1, so it's wider than the previous graph. Okay, now let's draw another one. So let's say if y is equal to 0.1, see this black graph over here, it's much wider than the previous two graphs. So as the value of a going towards 0, the graph goes more wider and wider. But if it's greater than 1 and keeps increasing, that makes the graph more narrow and narrow. Okay, so that is about this constant a over here. How about this constant c? What does this constant c will do to the function? So we're gonna look at that too. So this c value here basically so vertically shift your graph. So the c value gives you the vertical shift in the graph. Okay, so let me go back to the graph again. So if I am here, okay, so I got y is equal to x square. Okay, let me go back here. And more. So we got y is equal to x square, and there is a constant, let's say 2. So what does this constant do to the graph? What will happen to the graph when we have this 2? If it's positive, negative, we'll look at it right now. Okay. So we got the original function. The second function is y is equal to x square, and we got plus 2. And you see this graph shifted vertically upward. Okay, so if the constant is positive, this will shift your graph vertically upward. Now what will happen if, let me change the color of this one here to as green. Okay, now if it is negative, let's write that down too. So we got x square, and I got negative 2. See, this is the original graph. When the constant is positive, it shifted my graph vertically upward here. But when x is the constant is negative 2, it shifted my graph from 0, 0 to this negative 2 point. So it shifted downward. Okay, let's go back here. So this basically is a vertical shift. Vertical shift. Positive value gives you upward shift, I'll say. And if it's negative 2, let's say x is a negative 2, negative value will shift your graph downward. So bring your graph down, or shift your graph to the downward. And now, how about if we change the value of this x over here, which is basically b value? So let's say y is equal to now x plus 1 square. Okay. So what will happen to the graph? So this was a vertical shift. So this one is called horizontal shift. This gives you a horizontal shift in the graph. But again, remember, in this case, if it is positive, okay, then the shift is to the left. If it's a negative, shift is to the right. So it does the opposite of it. Here, if it's positive, it moves upward, negative downward. But here it does opposite of the sign. Okay, let's look at the graph. Then you can visually see it. Okay. So now we got x minus 1. I'm gonna put parentheses there and here. You see? Uh-oh. Let's rewrite it. So we got y is equal to x square. So that's the regular graph. Now y is equal to, instead of x, let's say it is x plus 1 square. You see? So it's plus 1, but shift is towards the left. So it does the opposite. Okay. So it's a horizontal shift. Now if it is a negative 1, it will shift the graph towards the right. Okay. So y is going to be equal to x minus 1 square. See, this shifted your graph to the right. Before, when it's positive 1, it shift to the left. Negative 1, it shift to the right. So your vertex will shift accordingly. So this value, this is basically v value, is your horizontal shift. And if it is positive, the graph will shift to left. And if it's a negative value, the graph will shift to the right. Okay. So now the other thing is, if we add both the shift into the function, what it may look like. Okay. So we got a vertical shift and horizontal shift. The equation will look like y is equal to a into x minus b square plus c. So that's how the equation will look like. So this b is your horizontal shift and this c is your vertical shift. And in some cases, this equation, you might see it r might be y is equal to a into x minus h square plus k. And this is called the vertex form of quadratic, vertex form. So this h and k value basically are your vertex. So vertex of your quadratic is now opposite, so it's a negative, so you're gonna use positive, and same h and k. Opposite, same. If it's a negative, this is positive. If it's positive, this is negative. So opposite sign, same sign. So h comma k or b comma c. So gives you your vertex. And this a gives you your slope. So let me write down a general equation. Let's say I got y is equal to 2 into x minus 1 square plus 3. So slope is going to be this 2 and vertex is going to be, opposite sign of negative is positive and this 1 and same sign positive 3, so 3. So this is the vertex. And the y-intercept, let's find the y-intercept. So y-intercept means x is 0. So plug in x 0 over here. That gives me y is equal to 2 into 0 minus 1 square plus 3 is equal to 2 plus. So this gives you negative 1 square is positive 1 times 2 is positive 2 plus 3 is 5. So this is your 0 and a 5. So 5 is your y-intercept. You can use this y-intercept and a slope and a vertex to graph your function, the quadratic function. So let me show you how, just to see if this B and C are really our vertex points. Okay. So if I go to the graph again, come on, it's loading. So the function we got in our case is y is equal to 2 into x minus 1 square. You see the horizontal shift, x is a -1, so it's shifted to the right. If it's +1, it will shift to the left. And then we got the c value plus 3. See, it shifted the graph vertically upward because it's +3. Now look at this point over here. So this point is 1 and 3, which is +1 and 3, and this is our vertex, and that's why we used that in the formula. So that will be the graph of this function. So this point will be the vertex point, and you can find it just from the equations. So 1 and 3. Wonderful. So practice more, try to graph those functions. So 2 is your slope, and you see this point, x is 0, y is 5, your y-intercept. So that's where graph intersect your y-axis. All right. So you can use those points to graph your function, the quadratic function, or this parabola, you can say, the slope-intercept, not slope-intercept, the vertex form of the parabola. Next topic after the parabola is circles. Okay, so the equation of a circle is x minus a square plus y minus b square is equal to r square, and this is called the center radius form of a circle. Center radius form, or it can be, some places, x minus h square plus y minus k square is equal to r square. Okay, so this a and b, or h or k, gives you the center of the circle. So this a comma b or h comma k is the center of the circle. And if the center of the circle is just at 0, 0, this point, then the equation of circle is x square plus y square is equal to r square. Okay. And if the equation of circle is given in a in general form, so general form of circle is ax square plus by square plus cx plus dy plus e equal to 0. So this is the general form of the circle, and they ask you to find the center of a circle or the radius of a circle. What you need to do, you need to convert this standard, you need to convert this general form to this form over here, or the center radius form. To do that, you need to use a method called complete the square. Complete the square, and we're gonna use one example here to do that. So before that, let's look at the graph of a circle. if we write equation in this format, what it will look like. We go back to the decimal. Okay, so we got, let's say I got x plus 4 square plus y plus 2 square equal to, sorry, 49. See, this is our circle over here. Let me make it a little smaller. And if you look carefully, this 4 and 2, remember the general formula is a negative x minus h square y minus k square. So my center is a negative 4 and negative 2, and that's what it looks like. So negative 4, x value is a negative 4 here, and y value is a negative 2. So this point over here is my center of the circle, and you can see it looks like a center of a circle. And r square is 49, so radius is r square is equal to 49. That gives me r is plus 9 or minus 9. So if, let's go back again, x is negative 4 and y is 2 here. X is negative 4 and then y is 2 points down, 1, 2. So this is my center, and you can count the points. 1, 2, 3, 4, 5. Oh, sorry. Square root of 49 is 7, not 9. Yeah, and that's what you see. 4 and 2. So 7 to the left, 1, 2, 3, 4, 5, 6, 7. So radius is 7. And same thing to the negative side, gives you the 7. Okay, so that's what it will do. Now what we need to learn, how to convert the standard form of a circle to center radius form to find the center and a radius. Okay, let's write down one equation and solve it. So the equation I got here is x square plus y square plus 8x plus 4y minus 29 is equal to 0. So first step is we're gonna combine the x terms together and y terms together, and I'm gonna move the constant to the other side. To do that, I'm gonna add 29 on both hand sides, right? So that'll cancel 29 over here. So I'm gonna write x square, and I'm gonna bring x term close to the x square, which is 8x. And then you got y square plus 4y, and this is going to be equal to 29. Okay, so second, this is the step 1. Step 2, that's where we're gonna complete the square. So in step 2, what they do, the coefficient of x, look for the coefficient of x and divide it by 2. So 8 divided by 2 gives me 4. And then find the square of that, gives me 16. Same thing for this y, the coefficient of y, 4, divide it by 2 gives me 2, and find the square of that, gives me 4. Okay, so we're gonna add this 16 and 4 on both hand sides. So let's do that. So we got x square plus 8x plus this 16, and then we got plus y square plus 4y plus this 4. Okay, and it will be equal to 29. As we added 16 on left hand side, we need to add it on right hand side too to balance the equation, and same thing for the other. So 16 plus 420, 16 plus 420. So if we add 20 on left hand side, we need to add 20 on right hand side too. So now so these two equations are perfect square. So how to write it? X plus, make half of this coefficient b value, half of 8 is 4, and put square on it. That's it. Plus the second one gives me y square plus 4y plus 4, half of this 4, which is 2, so this is basically y plus 2 square, is equal to, and add these 29 plus 16, 39, 6, 49, 45, 49. So this gives me 49. Now you see this equation is in center radius format. So you can find the center here. So center is going to be, you can compare it with general x minus h square plus y minus k square is equal to r square. So h, this is plus, this is minus, we're going to use a negative 4, and k is a negative 2, and r is going to be, r square is going to be 49, and you solve it for r. I hope this makes sense. So we convert the general form to the center radius form to find the center and the radius. So what we used, complete the square method. So complete the square. And see what we did, we moved this constant to the other hand side, put x terms together, y terms together, then divide the coefficient of x by 2 and square it. Same thing with coefficient of y by 2 and square it. Add both to one in the x, one in the y, and add on the right hand side too, and then find the factors, which is basically the completing the square thing. Which easier way is half of this x, which is 4, put square, half of this coefficient of y, which is 2, and put square. That's it. So that is all about the circles, the basic things you need to know. Now let's go over some geometrical terms in a couple of pages. Okay. So let's talk about angles. Okay. What did I wrote? Angles. Okay. So let's say, gotta correct system. So x, y. So this angle here, the 90-degree angle, they call it right angle. Right angle. So this is basically 90-degree. Then comes acute angle. If the angle is less than 90-degree. Okay. So acute angle. So this angle is less than 90-degree. The other thing called obtuse angle. So this is basically more than 90-degree but less than 180. So this line, okay, let me make that one too. A straight line makes an angle of 180-degree. Okay, so this total angle is 180, and this red line makes this angle, which is greater than my right angle but less than my 180-degree. So that angle is called obtuse angle, which is more than 90-degree but less than 180-degree. Okay, so next thing called complementary angles. Complementary angles. Two angles whose sum is 90-degree. So let's say this is a 90 degree and there are two angles that makes this 90 degree. So let's say this is 40 degree and this one is 50 degree. So two angles whose sum is 90 degree, two angles whose sum is 90 degree called complementary angles. And supplementary angles, let's write down that. Supplementary angles. So that'll be two angles that make, or whose sum is, not sum, S-U-M, sum, 30 and 50. So those angles called supplementary angle. Two angles whose sum is 180 degree are called supplementary angles. So you can remember those. I always get confused till days which one. I'll forget the supplementary and complementary. So what the trick I use, I'll write C and S. So C in alphabet comes first, and I know one of them is going to be 90, other is going to be 180. But if I confuse, I'm not sure which one was supple or which one is couple. I'll write C and S, 90 and 180. So C comes first in alphabet and 90 comes first in your numbers. Then S later and 180 later. Bingo. Even if you forgot which one was complementary. So complementary is 90, supplementary is 180. Again, I'll write C and then I write S. And C comes first in alphabet and 90 comes first before 180. So C in 90 in front of C and 180 in front of S. So this is just a trick. And once I just made up by me. I don't know. You can make your own trick, or you can use this. There you go. If you ever get confused or forgot which one was supplementary or which one was complementary. I personally used to forget a lot about this, and that's what I learned, or I made my own trick. Okay, so that's all about the angles. So they give you angles and make some question about find this angle, the angles are supplementary or complementary. Again, the problems are not going to be straightforward, so they are little, you need to use the critical thinking there, but you need to know the basics, and this is the goal of this video. And let's go over a few more things. So angle, the sum of angles in a triangle. Let's say A, this is B, and this is C. The sum of angles in a triangle is equal to 180 degree. And if we got a circle, and there are, so this circle complete, so there are 360 degrees in a circle. And the straight line, I already said, makes an angle of 180 degree. Okay, so few more things. Let's go over some triangles. Then we'll be done, almost there. So triangles. So one of them I'm gonna write down equilateral triangle. Equilateral triangle. So that's where all the sides are equal to each other. All the sides are equal, all the angles are equal to each other too. So let's say if this is X, this is Y, this is Z. So X degree is equal to Y degree is equal to Z degree, and it's always 60 degrees. So each angle is 60 degree. And you add them, 60, 60, 60, total is 180 degree. Second type of triangle, isosceles. Isosceles. isosceles where two sides are equal. Let's say A, B and C. So this angle will be equal to this angle and these sides are equal. So their opposite angles will be equal to each other. So side AB is going to be equal to side AC. And let's say this angle is B degree and this angle is C degree. So B angle will be equal to C angle. So these two angles will be equal to each other in isosceles. And the special form, we call it right triangle. So in the right triangle, one of the angle is a right angle or 90-degree angle. So let me draw it here. So let's say, okay, so this angle is 90 degree or right angle. And let's make A, B and C, and this is another given angle. So the side to this given angle is called adjacent and this is called your opposite, so opposite to this angle, and this side is called your hypotenuse. Okay, so this is your right angle triangle, and we used to call this as a base, and this is perpendicular, this is hypotenuse. And from the right triangle there is another theorem called Pythagorean theorem. Which is very useful in geometry. It says the square of hypotenuse is equal to the sum of the square of other two sides. All right. So let's say if AB is equal to 1 and BC is equal to 2, it can be meter, centimeter, doesn't matter. So you can find AC. So in this case, AC is going to be AC square. So 1 square plus 2 square. Therefore, AC square is equal to 1 plus 4, or AC square is equal to 5. And therefore, AC is going to be square root of 5. So you can find, if two sides are given, you can find the third side by using Pythagorean theorem. And in a right angle triangle, there are two special cases. So one of them is, so we got a right angle triangle, let's say. The first special case is, call it 45, 45 and 90. So that basically means one angle is 90 degree, which is this one, and the other two angles are going to be 45. So this is 45 and this is going to be 45. This is a 90. So this is basically a right angle isosceles. You know, two sides are equal, two angles are equal. So this is called 45, 45, 90 degree right triangle. And the sides, the ratio of the sides in 45, 45 and 90 degree is 1:2. Let's say if this side is x and this side is going to be x because both sides are equal, then this third side, which is hypotenuse, is going to be x square root of 2. Okay, so if you know one side, you can find the third side because other two sides are equal. And the other special case is 30, 60, 90. Again, they all add up to 180. Okay, so in this case, one angle is, this is going to be 90 because it's a right triangle. So one angle is 30 degree, so other angle is going to be 60 degree. Okay, so I say A, B, and C. I'm gonna write A, B, and C. So the ratio of sides in this triangle is 1 to root 3 to 2. So for example, if one side is x, let's say this side, which is by angle 60 and 90, remember that. The other hypotenuse is going to be 2x, and this adjacent to this angle is going to be x root 3. How I remember? Wherever you put 33, put a 3 by that side. I don't know what I keep doing. Easy way to remember. So 2x here, x here, and 3 by 3. A trick again. So these formulas are really useful when you solve problems in geometry, sometime in algebra 2, or wherever you see the special type. So they give you one side, find the other. They gives you the angle, find the other angle. So problems can be asked in different ways. This is more important. You need to remember this. Okay. So the last topic on this video I'm gonna go over is logarithmic. Logarithmic. Gonna go over some rules, basic rules for log. So log is basically inverse function of exponential. Okay, but why we need a log? Let's think about it. So let's say if you got 2 raised to power 1, that gives you 2. 2 raised to power 2 gives you 4. 2 raised to power 3 gives you 8. So what power of 2 gives you? What power of 2 gives you 7? Think about it. How you can get what you raised, what should be this exponent to the 2, that gives you 7. We know if it's 4, it's 2, if it's 8, it's 3. But how about if the answer is 7, what will be this exponent over here? So to find this, we use logarithmic. Okay. So in general, it's written as log of base b of x is equal to y, which is basically identical to b raised to power y is equal to x. So you have a x, you need to find this y. So this log of x with the base b gives you y. Okay, and x is greater than 0. The base is always greater than 0, and the base can never be 1. Okay, so let's do some examples. So let me write down 2 raised to power 3 is 8. Okay, so our b is 2, our y is 3, and x is 8. So let's write this in a logarithmic format. So what that will look like? So that will be log, and we need a base. Base is this term over here. That one has exponent, so base is 2 here. Okay, and then x. So x in our case is 8. Okay, and this is equal to y. So y is your this exponent over here, which is equal to 3. See, we used log to find this missing exponent, especially this kind of problem if you don't know. Okay, so now let's say they give you example like log with the base 4 of x is equal to 2. Write this in exponent form. See, this 4 is your base here. Okay, and this is the exponent. So 4 is a base, which is b. I'm gonna write it here 4, and this equal to y. This is 2 y. This is your exponent. 4 raised to power 2 is equal to this x. So this is equal to this x. So this gives me x is equal to 4 square is 16. Okay, so therefore this is log of 4 of 16 is equal to 2. All right, so let's do another one. So if we got log with the base 10 of 1000 is equal to what? So this means this b, the base, goes to what power? Let's say goes to what x and is equal to this 1000. You can always compare to your standard equations if you ever get confused. So we know 10 raised to power 3 is 1000. So this missing number here is 3. And log with the base 10, log with base 10 is called common logarithm. Common logarithm. And log with base e, exponential number, which is approximately equal to 2.718. That kind of log is called natural logarithm, and it's written as ln, like ln 2 something. Okay, it's called natural logarithm. So next page we're gonna go over few properties of logarithm. So let's say you got log with the base b of x and y. This is called the product property. So this is basically equal to log of b of x plus log of b of y. And if it is a log of b x over y, it's called quotient property. So if it's in a fraction like this, we're gonna use a minus sign. Then it is log of b of x minus log of b of y. And the power property, if it's log of b and x raised to power a, then this power moves forward. We bring this power in front of log, so a goes there, so log with the base b of x. It can be written as a log of b a root, which will be half root, whatever it is going to be. It's going to be log of b of x over a, because it's a square root. Let's say log of b x raised to power 1/2 square root. It's the same properties. You bring 1/2 over here, it becomes a log b of x. Okay, so the other property is called change of base. So let's say if you got a log of a of x, so change of base, this one is called change of base property. So then this is going to be log of x over log of a. You can solve it by using this, or log natural of x over log natural of a. Doesn't matter, it gives you the same answer. Okay, and if you get b raised to power log of b of a, this is going to be just a, because this part over here gives you 1, which can be also written as log of b, base b, and b raised to power a. Whatever is the base and you got the same term with some power, this gives you answer a. For example, if you got log of 2 and 2 raised to power 3, answer is just 3. So these are some properties of logarithm you can use. Like here, if it's log of b, some number, let's say 18. 18 can be written as 2 times 9. It can be written as log with base b of 2 plus log base b of 9. So problem can be asked in different way, but you need to remember the basic rules. And that's what the motive of this video is. All right, so that's all I got. And there are like, few formulas like area of a circle, area of a triangle. I think you guys can find that in any books and review with the formulas. I don't want to write a lot of the formulas here because I already wrote a lot of formulas here. So please solve some examples and look into problems, and I'm gonna do some videos on problems too, like critical thinking videos of SAT and ACT math. So these videos were just to clear the basics. So the next few videos I'm gonna make is the problems. So those problems are not going to be straightforward, they are going to be more complex. That's where you're gonna use your critical thinking. Okay, so thanks for watching the video, guys, and please share with your friends and subscribe to the channel to support the channel. And I hope you're gonna do good on your test and exams. Stay tuned to my channel so that you won't miss any other video. Thank you. Have a good day. Bye bye.